Hello, we're here today with Ajith Mekkoth at Computex in Taipei. Ajith Mekkoth is Executive Vice President, AI and Chip Engineering at NXP Semiconductors. Hello. Today you had a keynote about right-size AI, so I'd like to ask you a few questions about it, because you are challenging the dominant narrative about bigger models, more compute. So first, I'd like you to explain what you mean by right-size AI and why more raw compute power is not necessarily the right matrix to follow.
Sure. Thanks for this opportunity. What I meant by right-sized AI is that different types of models have their place. So the Gen AI models come in various sizes. And there are also technologies like RNNs and CNNs, which are not generative in nature, which are smaller models. And what I mean is that for specific applications, you don't need the generative AI model. So it's more of a fit for purpose question. And select the right model that's applicable for the application at hand, and then use it as it's relevant, as opposed to sending everything to this big, huge model and expect it to do everything for you.
Having everything in the cloud, AI workloads in the cloud is not necessarily the best idea. And we are seeing more and more use of AI at the edge. So where do you see it more appropriate?
Yeah, so I think, like I said earlier, for the technologies like RNNs and CNNs, clearly edge is the place for it. The debate is usually about generative AI models. But even there, if it is for a single application as opposed to what we call batched application, where several inferences are happening together, you don't need to send all this data to the cloud because the token costs are too expensive, the latencies are too big. So my thesis and our thesis at NXP is that the technology in silicon has gotten to a point where you can do a significant amount of compute locally without incurring the token cost in the cloud.
Yeah, so it's no longer about maximizing compute, but more about optimizing compute.
Yeah.
But it's easier to say than done.
It is. And I think, again, there is going to be a sweet spot of where, from a business model standpoint, it makes sense to leverage the cloud versus local compute, because the cost of the device may end up being slightly higher if your volume is low. But for large volume devices, you certainly have much more return on investment if you do it locally. So it's a trade-off of where that curve intersects and at what volume does it make more sense to do it locally, and at what volume would you rather just pay for the compute in the cloud.
Okay. So are we at a tipping point where it's going to make more sense economically to have AI inference at the edge for some applications?
Yeah, I think for most of the applications for personal use, I think local AI would be better.
Okay.
Now, in industrial and other enterprise use case, there may still be a trade-off, but we believe that curve towards more AI at the edge is coming sooner than later.
Okay, but adoption is still not there yet. When we talk about scaling, we tend to wonder why it's not going as faster. So why is that? What are the technical barriers for your customers? Essentially, what are they telling you? Why is deploying AI at the edge is not so easy at this point?
We believe it's not just an AI problem, it's a problem of system design. And the question there is, what do you need around the AI to make that application successful, whether it's a vision use case or some other type of motor control application. So it's a question of, do we have the right size of system built around the AI that is economically viable? And once more of these optimized systems become available, then this trend to the edge becomes more and more easier. And right now we're seeing in many cases a large AI system being bolted onto something else that was not designed to be working with AI. So there's a bit of a mismatch. So these optimized systems, and I called in my presentation this morning a system balance. Once the system balance shows up more and more in the real world, then you would see an optimization for the application, and that would make it easier.
Talking about real world intelligence, well, NXP claims that it has scalable AI solutions with real world intelligence available. So if you want to say a few words about
and in my talk this morning, I had three specific examples. One was a motor control application where you have an industrial motor that needs to be managed, balancing the determinism versus the AI adaptability of the system. And we believe that with the MCUs that NXP has, where motor control can be integrated with some amount of AI, we are able to do this very effectively under the power and the cost envelope. I had the example of a voice application. And in the voice application, we were talking about a human-machine interaction. And in those cases, especially in noisy environments, it is not just about speech-to-text conversion. You need the context of what's happening around. And so you need to bring in other sensory data, and it could be based on proximity of who you're talking to, or authenticating to the person who's communicating with the machine, etc. And here NXP is able to bring technologies to the table which allows for not just the voice suppression, but also the speech combined with the voice together to give better meaning to what has been communicated. And the third case was this application for motor control, for robotic control, and there are new models called VLAs, and we are able to demonstrate that we are able to do VLAs in a very cost-effective manner at the edge. So it shows this complete scalability of solutions that makes it very easy to bring applications to the edge.
I see. Last year, NXP acquired Kinara, and it brought in its fold, its processing technologies and discrete NPUs. What is good about those discrete NPUs when it comes to integrating the right size of computer architecture?
Yeah, one of the main drivers for that acquisition was this generative AI technology that Kinara brought to the table. We already had other AI technologies in-house, and so with generative AI, now we are able to complete that full portfolio along with existing technology and pair discrete NPUs with our application processors to scale it as the customer needs. So that has gone very well. And now we are able to demonstrate how we present that as applications to customers. So what you have here is one of our i.MX processors. This is an i.MX 9.5, and underneath here there is the ARA discrete NPU, which provides us the capability to have Gen AI at the edge. And now the combination of the ARA process, the i.MX processor with the ARA, we are able to do now very sophisticated use cases like video search, or you can have agentic orchestration and so on. So I think this really, the ARA discrete NPU has really helped us scale to a different level of edge AI computing than we had before.
Okay, and I guess that their software toolchain was part of the appeal when you acquired Kinara.
Yeah, so for Gen AI, they had a good set of tools to bring cloud models to the edge. So we are integrating that along with the rest of our EIQ software portfolio. And I presented this morning how the Gen AI flow now is incorporated into our larger portfolio of software tools.
So we mentioned power efficiency, we mentioned latency, but there's a key advantage about edge AI is data privacy and security, and that's the EU angle that I'm bringing with the European Cyber Resilience Act coming into force. We pay attention to security, data privacy. Do you want to say a few words? Is it going maybe to accelerate or foster adoption of edge AI?
We believe so, and that is certainly our thesis as well, that with local control of data, you're more, the owner of the data is more in control, and you're not relying on sending information to the networks and risk losing control of the data. In addition, even in industrial environments, we are now going into applications like AI Hub, where you can centralize the data in that premise, whether it's a factory or a home. So instead of having data distributed in many different devices in an environment, you're able to also centralize it and protect it much better in one place in that environment.
Okay, I see. So we are at Computex. It's the end of the first day. That's a conclusion. If you want to tell us about what you felt, what your feedback, what surprised you the most, or how you feel about the show.
Yeah, I didn't get too much of an opportunity to walk around, but I went through the area where they had robotic demos. It was again amazing to see the local ecosystem, how they come together to build various parts of a humanoid and various parts of a robot, and embrace new technologies and build products very fast. So speed is amazing here. So it always never ceases to amaze me how fast people are able to get products into the market here.
Thank you so much. It was a pleasure, and I wish you a great show.
Thank you very much.
Thank you.
Thank you.